Physics 182ers is the problem that we set up in class the other day. You started working on the board, and I just wanted to make sure that we're all in the same place on it. So I'm walking you through at least the setup of the problem the way I would do it. We've got a 25-volt battery here, power supply of some sort, 122 ohm resistor, 5.6 ohm resistor, and 75 ohm resistor, and a 5-volt power supply this way. So we need three equations. There's a current in this branch, a current in this branch, and a current in this branch, and those three currents are different. I'm calling this current 3, I3, this current 2, and this current 1. Current 1, I'm going to say, flows this direction, comes into this junction, and current 2 goes out, and current 3 goes out this way, so that I1 equals I2 plus I3. That's one of my equations that I can use to try to find the three currents in this branched circuit. And then I walk two loops, and I can walk this loop, or I can walk this loop, or I can walk the big loop. I need two independent loops, and I can do any of those. I'm going to walk this loop, and I'm going to walk this loop. As I step, I'll start here. As I step from this side of the battery to this side of the battery, I get 5 volts, plus 5 volts, going from the low side to the high side. I'm going in the direction of current 3, so I'm going to have a minus I3 times 75 ohms. And then as I continue to walk around this loop, I'm going against current 2, so I'm going to have a plus I2 times 5.6 ohms. That's the potential difference as I step across that resistor. And then I get back to the starting point, so that whole thing has to add up to 0. I walk the other loop. I got 25 volts going from here to here. I go in the direction of I2, across resistor, through resistor, 5.6 ohms. The current goes through it. The potential across it is IR, so there's 5.6 ohms times I2, and then I'm going in the direction of the current here, so it's also a minus 122 times I1. I wrote I3 there, so I'm in the wrong place. Yeah, 122 times I1. I'd already gone on then to the next step to say at that point there's a lot of different ways you can do it. You got three equations and three unknowns. If you've done linear algebra and you want to just use your matrix to solve this set of equations, that's great to go ahead and use matrix methods to do that. One way is just to substitute in, sort of straightforward, and to say I1 is I2 plus I3, so I put that in for I1 right there. And I've got this, and then I can solve this for I3. So all I did here was just put in the 122 ohms times I1 plus I2 plus I3 that goes in for I1 right there. So now I've got this equation in terms of I2 and I3. If I get rid of I3 right here, I can solve this for I3 and say I3 is 5 volts minus I2 times 5.6 ohms divided by 75 ohms. And that would go in right here for I3. Let's see if we can actually do that algebra and say we've got 25 volts minus I2 times 5.6 ohms minus I2 times 122 ohms minus 5 volts over 75 ohms. That's the first term right here. And minus, that's times 100, that's I3 times 122 ohms. Minus I2 times 5.6 ohms. I2 times 5.6 ohms divided by 75 ohms. But that whole thing still times 122 ohms. Okay, so now we've got everything in here. It's known except for I2, and all we have to do is solve for I2. We can gather the terms that don't have I2 in them on the other side. Actually, let's pull the I2 terms to the other side. And we're going to get I2 times 5.6 ohms times plus, that term went over to the other side, everything's plus, we moved over to the other side, plus 122 ohms plus 122 ohms times 5.6 ohms divided by 75 ohms. All of that is equal to what's left over on the other side, which is 25 volts. What do we have? Are there any other terms that right there? minus 5.00 volts over 75 volts times 122 ohms. Okay, so I2 is what I'm going to get right here, is equal to 25 volts minus 5 volts over 75 ohms. I wrote volts there. And 122 ohms divided by that whole thing. That's right there, which looks like 127.6 ohms plus 122 ohms times 5.6 ohms, I'm thinking is what that is. Can't read my writing, of course. Divided by 75 ohms. So that whole thing on the bottom is 122 times 5.6 is divided by 75 is 9.1 ohms right here. 9.11 ohms. So that whole thing's going to be about 136.7 ohms is what that whole thing on the bottom is going to be. 136.7 ohms. Up on top here, we've got 122 divided by 75 times 5 is 8. Does that make sense to us? That makes sense to us. 8.1 volts. So this whole thing looks like it's 33.13 volts divided by 136.7 ohms is 33.13 divided by 136.7 is 0.24 amps. So it looks like we got 0.24 amps for 0.242 if you want to keep an extra digit or two as you do the rest of your calculations. That's what we calculated for I2. Because it's positive, the direction we assumed for that current was correct, so I2 will flow left to right in that middle branch, and it will have a value of 0.24 amps. Now, if we want to find I3, we can go right back to this equation that only has I3 and I2 in it, and we put in what I2 is and solve this for I3, and then I2 plus I3 is going to be equal to I1. And we can work our way through there, but I think I've bored you enough with that, and you can finish that off. So check that, see if it looks like what you got when you worked through it, see if you finished working through it, if this is the way you set it up in class the other day. And that's our multi-branch circuit problem. Thanks, everybody.